Okay, let's take a look at this example. Here, we would like to solve this question. So let's have the solution. Okay, a right circular cone of base diameter 48 centimeters and height 60 centimeters has the same volume as a solid cylinder of height 80 centimeters. Calculate the diameter of the cylinder. So we see here that we have a couple of two different solid shapes having the same volume. The first one is the right circular cone. So I can quickly draw out a replica of the cone. Right circular cone simply means that the vertical height is perpendicular to the circular base of the cone. So let's take note of that. Okay. This is the height of the cone, height h, and that is given to us in the question as 60 centimeters. Okay. The diameter of the cone, which is the length from a point on the circumference of the circular base to another point, passing through the center, diameter, so we have 48 centimeters. We should quickly recall that the diameter of a circle is actually twice the radius. Okay, so we can calculate the radius by simply dividing the diameter by 2. So diameter divided by 2 should give us the radius. So in the case of this example, that simply means I can have my radius to be equal to 48 centimeters divided by 2, which will simply give me 24 centimeters. So the radius of the circular base of the cone is 24 centimeters. Remember, we are actually comparing two solid shapes. The first one is a cone, and the second one is the cylinder. Remember, we're told in the question that they both have the same volume. The height of the cylinder was given as 80 centimeters, but they did not give us the radius. So let me call that R. Or just for simplicity, so that we can differentiate between the radius of the cone right here, differentiate it between that of the cylinder, let's call that of the cylinder probably X. So if you call the radius of the cylinder X in this case, then we know what we're looking for. Okay, what we know about this question is that the volume, okay, of both shapes are considered to be the same. So I'm going to say that they are both equal to each other. So the next thing we have to do is to remember the formula for both of them. So therefore, I can quickly say this. Okay. The volume of the cone is expected to be equal to the volume of the cylinder. So you quickly recall the formula for the volume of your cone. Volume of cone is 1/3 pi r squared h. while the volume of cylinder is given as pi r squared h. Substituting for your values, this is 1 over 3 multiplied by pi multiplied by r squared. R here is the radius of the cone. So the radius of our cone already calculated here is simply given as 24 centimeters. So let's just have 24 substituted over there. Okay. And then you multiply by the height. Don't forget to square your radius. 24 squared. The height of the cone is 60. And that will be equal to pi again, multiplied by r squared. Now, I decided to change the radius of the cylinder to represent it as x. So instead of r, I'm writing x squared. Then multiply by the height of the cylinder, which is 80 centimeters. So I drop 80 here. Okay. Of course, from both sides of the equation, I have pi here and I have pi here. So that should mean that the 2 pi's can easily cancel out from both sides of the equation. To leave me with 24 squared, which is 24 times 24, and multiplied by 60, and I have that to be equal to, okay, don't forget to divide this by 3, so that this can be equal to 80x squared when you multiply on that side. So solving all of this, you're going to arrive at, well, let's just do the solution here. 3 could go here, 1, and then 3 could go in 60, 20, and then 24 times 24 times 20. You quickly calculate that, and I have it to be equal to 80x squared. So 24 times 24 times 20 is going to give you 11,520, and that equals to 80x squared. Of course, dividing both sides by 80 so that I can have my x squared to remain alone. This goes here, 1 here, 1. 11,520 divided by 80 should give us 144. So 144 equals to x squared. Therefore, x will be equal to the square root of 144, and you find out that is equal to 12 centimeters. But guys, the question asks that we should calculate the diameter, okay, of the cylinder, not the radius. We have only calculated the radius, okay? So take note that this answer here is the radius of a cylinder. So since we have to calculate the diameter, so we can then conclude that therefore the diameter of the cylinder will therefore be equal to twice of the radius, which is x, and that will be 2 times 24, 2 times 12 centimeters, to simply give us the answer to be equal to 24 centimeters, and that is the diameter of the cylinder. I hope that is very clear and understandable. Okay, let's move on to the next question.